class, let us first start with the lemma. So the lemma states that the interval, open interval a to infinity is measurable. So നമ്മൾ prove ചെയ്യേണ്ടത് a to infinity measurable ആണെന്ന്. So we need to show the condition. So m star of a. So we are going to show that m star of a is greater than or equal to m star of a intersection e plus m star of a intersection e complement. So if for any set a belongs to R, if m star of a greater than or equal to m star of a intersection e plus m star of a intersection e complement, then we can say that the given set is measurable. So here the set E will be the open interval a to infinity. For proving the lemma, we will be using this result. So if you are having any subset A of R, then given any epsilon greater than 0, there exists a countable connection. The sequence in of open intervals in such that A is contained in union in and summation length of in will be less than m star of A plus epsilon. So if A is any subset of R, then A will have a countable cover, and you can, and for any epsilon greater than 0, so you can find an epsilon greater than 0 such that summation length of in will be less than m star of A plus epsilon. So you can find such an epsilon. So using this result, so we will be using this result in the proof. Okay. അപ്പോൾ നമുക്ക് എക്ക് ഒരു കൗണ്ടബിൾ കവർ കണ്ടുപിടിക്കാൻ പറ്റും. So let me take that to be sequence in. So we are having a countable collection of open intervals covering A. So summation length of in will be less than m star of A plus epsilon. So here we have the real line. This is the point A. So this is a point A, and this is the set A to infinity. A to infinity വരെ കാണിച്ചിട്ടുണ്ട്. എക്സ്റ്റെൻഡ് ചെയ്ത് പോകുന്ന റിയൽ ലൈന് ഇത് minus infinity to A. So let me take this interval to be one of the ions. So you can find for each in, so നമ്മുടെ A എന്ന് പറയുന്ന A will be contained in union in. So for each n, suppose there is an intersection with the interval. So it can have an intersection with the interval a infinity or minus infinity to A, and let us take in dash to be the intersections with minus infinity to closed A, and in double dash to be the intersection with A to infinity. അപ്പോൾ ഫിഗർ നോക്കിയാൽ in കാണിച്ചിട്ടുണ്ട്. in എന്ന് പറയുന്നത് ഒരു ഓപ്പൺ ഇന്റർവൽ ആണ്. So the intersection of in with A to infinity, that will be in double dash, and intersection of in with minus infinity to A, that will be in dash. So in will be union of in dash and in double dash. So therefore length of in will be equal to length of in dash plus length of in double dash. So then let us call that as result 2. So you have result 1 as this, and this is result 2. So length of in dash plus length of in double dash will be equal to length of in. Since union in is a cover of A, so let us now use this fact that A is contained in union in. For A intersection, the set minus infinity to closed A will be contained in union in intersection minus infinity to A. Since A is contained in union in, so this intersection will be contained in union in intersection minus infinity to A. Now we can take union outside. So that will be union of in intersection minus infinity to A. In intersection minus infinity to A will be in dash. So therefore A intersection minus infinity to closed A will be contained in in dash. Now since you have in the form A contained in B. So if A is a subset of B, then we know that M star of A will be less than or equal to M star of B. So here we have got that A intersection minus infinity to A is contained in union I n dash. So M star of A intersection minus infinity to closed A will be less than or equal to, so this is closed interval A, that will be less than or equal to M star of union I n dash, and this is again less than or equal to M star of union I n dash. I n എന്ന് പറയുന്ന intervals ആണ്. So since it is countable additive, so M star of union I n dash will be less than or equal to summation M star I n dash, and that will be equal to, in the INs are intervals, so this will be equal to length of IN dash. So call this as equation 3, and same way you can do for the interval A intersection open interval A to infinity. Again A is contained in union IN, so this will be contained in union IN intersection A infinity. In union you will get union of IN intersection A to infinity, and this is going to be IN double dash. So A intersection A to infinity will be contained in union IN dash again by the property. So take M star. So measure M star of A intersection A to infinity will be less than or equal to M star of union IN double dash. Countably additive ആയതുകൊണ്ട്, so you will get less than or equal to summation M star IN double dash, so which is equal to length of summation length of IN double dash. Now combining these two equations, we will get M star of A intersection A to infinity plus M star of A intersection minus infinity to closed A, that will be less than or equal to summation length of IN double dash plus length of IN dash. ഇനി നമ്മൾ നേരത്തെ കണ്ടു length of IN double dash plus length of IN dash എന്ന് പറയുന്നത്. So this IN dash and union IN double dash, that will be equal to IN, and these are disjoint. So the sum of these two lengths will be equal to length of IN. So this will be equal to summation length of IN. And now by the first result we have seen, this will be less than M star of A plus epsilon. So we will get M star A intersection open A to infinity plus M star A intersection minus infinity to A, that will be less than M star A plus epsilon. Now this will hold for all epsilon greater than 0. Now when you take epsilon equal to 0, we will get the required result. So epsilon is arbitrary, so we will get M star of A greater than or equal to M star of A intersection A to infinity plus M star of A intersection minus infinity to closed A. So this നമ്മൾ ഏറ്റവും ആദ്യം കണ്ട ഡെഫിനിഷന്റെ മെഷറബിലിറ്റിയുടെ ഡെഫിനിഷന്റെ ഫോമാണ് M star of A is greater than or equal to M star of A intersection E plus M star of A intersection E complement. So therefore you can conclude that the open interval A to infinity is measurable. And now let us define what is called as Borel set, and we will show that every Borel set is measurable. Now by Borel set you mean, so Borel set is actually an element of a Borel sigma algebra. Now Borel sigma algebra we mean that is the smallest sigma algebra containing all the open sets. Okay, അപ്പോൾ നമ്മൾ open sets എടുക്കുകയാണെങ്കിൽ നമ്മൾ sigma algebra പറയുമ്പോൾ sigma algebra must be closed under countable union, and it must be closed under complementation. So if a set is open, then its complement will be closed. So Borel sets are sets that can be constructed from open or closed sets by repeatedly taking countable unions and intersection. Again it will be closed under intersection also. നമ്മൾ ആദ്യം algebraic sigma algebraic definitions കണ്ടപ്പോൾ നമ്മൾ ചെയ്തിട്ടുണ്ട്. So it will be closed under unions and intersections and complementation. So collection script B of Borel sets is the smallest sigma algebra containing all open sets. So by Borel sigma algebra, that we mean that's a collection of open and closed sets such that it is closed under complementation, countable union, and intersection. So the sets in the Borel sigma algebra, they are called as the Borel sets. Now we can actually show that every Borel set is measurable. So every Borel set in the variable, that will be either a open interval or open set, or open set or closed set. So we can eventually conclude that every open set and every closed set is measurable. So that is the theorem we are going to see. So നമ്മൾ ഇപ്പോ കണ്ട ലെമ്മ അതിന്റെ അകത്ത് യൂസ് ചെയ്യും. ഓക്കെ, so നമ്മൾ ഇപ്പോ കണ്ട ലെമ്മ അനുസരിച്ച് when you take the interval of the form a to infinity, that is measurable. A to infinity measurable ആണെങ്കിൽ, so it belongs to the measurable space, script M, which is a sigma algebra. So അതിന്റെ complement measurable ആയിരിക്കും. So minus infinity to closed A will be measurable. Now let us look at other forms of open intervals. So you can have open interval of the form minus infinity to A, or open interval of the form AB. അപ്പോൾ നമ്മൾ ചെയ്യാൻ പോകുന്ന ഇതാണ്, നമ്മൾ ആ സെറ്റ്സും മെഷറബിൾ ആണെന്ന് കാണിക്കും. ആൻഡ് ദെൻ നമ്മൾ ഏതെങ്കിലും ഒരു ആർബിട്രറി ഓപ്പൺ സെറ്റ് എടുത്തു കഴിഞ്ഞാൽ ഓപ്പൺ സെറ്റ് ക്യാൻ ബി expressed as a union of open intervals, again by the property of measurable space. So we will show that any open set is measurable. If any open set is measurable, so automatically adinte complement ellam closed set aayirukkum, that will be again measurable. So let us use the previous lemma to prove the theorem. So theorem is every Borel set is measurable. In particular, each open set and each closed set is measurable. So by the previous lemma, we have that so the interval of the form a to infinity is measurable for all a belongs to R. Now since M is a sigma algebra, so M is the collection of all measurable sets. So since M is a sigma algebra, so the complement of so this is a complement, so complement of the interval a to infinity is also measurable. Now the complement of the interval a to infinity will be minus infinity to closed A. So we can conclude that minus infinity to A is measurable. Now let us look at open sets എടുക്കുമ്പോൾ open sets will be in the form minus infinity to A to infinity or A to B. അല്ലെങ്കിൽ രണ്ടും ഇൻഫിനിറ്റ്, ഏതെങ്കിലും രണ്ടിൽ ഇൻഫിനിറ്റ് വരുന്ന, അല്ലെങ്കിൽ open interval AB. So we already know this, A to infinity measurable ആണ്. So we will show that again these two are measurable. Okay, and now since minus infinity to closed A is measurable, so using that we will show that minus infinity to open A is also measurable. Now minus infinity to open A can be written as union n equal to 1 to infinity minus infinity to A minus 1 by n. So the union of this will be equal to minus infinity to open A, minus infinity to A minus 1 by n closed on the right side. As we know, minus infinity to closed A, നമ്മൾ complement എടുത്തു, A infinity യുടെ complement ആണിത്. Now we know that a set of this form is measurable. Now നമുക്ക് M എന്ന് പറയുന്നത് sigma algebra ആണ്. So these are all measurable sets. So by countable additivity, again this is a countable union. So countable union is again measurable. So countable union of measurable sets is again measurable. So this is measurable. It is measurable ആയിരിക്കും, countable union ആയതുകൊണ്ട് ഇത് measurable ആണ്. So therefore we can conclude that minus infinity to A is measurable. Now next we need to look at interval of the form A to B. A to B where B is strictly greater than A.
So consider these two intervals, minus infinity to b. അപ്പോൾ നമ്മൾ ഓൾറെഡി പ്രൂവ് ചെയ്തു മൈനസ് ഇൻഫിനിറ്റി ടു ബി ഫോമിലുള്ള ഇന്റർവൽ മെഷറബിൾ ആണ്. ഇത് നമുക്ക് ഓൾറെഡി ഉള്ള